We are finally on the discussion regarding what are gas laws. Now we are done with the factors affecting the gas laws and the different conversions, no, based on the previous videos, no, na ginawa ko. So today we'll focus, no, on the gas laws, specifically Boyle's Law, Charles' Law, Avogadro's Law, and combined gas laws. So we'll be combining these gas laws. So take note, gas laws are based on the idea that gas particles are far apart. No, they are moving freely and collide with each other. And of course, an example of container walls, which is described by the kinetic molecular theory, which I have discussed on the previous video. So in simple terms, gas laws explains things like, so the first one is Boyle's Law. So from the word or from the law itself, no, it is obvious who, kumbaga, proposed it, no? So of course ang kanyang surname is si Boyle, no? So specifically si Robert Boyle. So Robert Boyle was born at Lismore Castle, no, Munster, Ireland. The 14th child siya, no, of the Earl of Cork. So Boyle's chief scientific interest was chemistry, but his first published scientific work entitled New Experiments Physico-Mechanical Touching the Spring of the Air and its Effect in the year 1660 concerned the physical nature of air. So he studied air. This was shown in his experiment where he used an air pump to create a vacuum. Okay, so the second edition of this work, after 2 years, in 1662, described the quantitative relationship that Boyle derived from the experimental values presently known as Boyle's Law. So this law describes pressure-volume relationship in gases. So when temperature stays constant, so this is the condition. The temperature should be constant in order for Boyle's Law to govern or to occur. Okay? The pressure and volume are inversely proportional if temperature is constant. It's one of the earliest gas laws in chemistry and physics, no, ang Boyle's Law. Pressure and volume move opposite with each other. So, if mag-decrease ang volume, mag-increase ang pressure. If mag-increase naman ang volume, mag-decrease naman ang pressure. So, as what I have said, no, kanina, at constant temperature, the pressure of a fixed quantity of a gas varies inversely with the volume. So, constant lang yung ating temperature. Ang volume natin pagtataas, ang pressure bababa. Pag ang volume naman natin is bababa, ang ating pressure naman is tataas. So, ganun lang. This means that if the pressure in a gas sample is increased without changing the temperature, the volume of gas will decrease proportionally, or that if the pressure in the gas is doubled, the volume will be half. Okay? So in here, on this example, as what you can see, so there is pressure, no, na tinutulak ng piston. But as what you notice, the more pressure na ipupush natin dito sa ating cylinder, the more na ang volume is liliit. Right? Okay. So ito yung formula for Boyle's Law. P1 times V1 is equal to P2 times V2. So, take note, P stands for pressure and V stands for volume. So this is our formula. And it can be written as this one. If, ganito, in solving gas laws, there will be given na mga quantities, no? For P1, meaning pressure 1, P2, pressure 2, volume 1, and volume 2. So, either dito sa apat is meron tayong hahanapin. So, if P1 yung hinahanap natin, so the formula should be like finding the P1. So, in mathematics, 'di ba? If meron kasama dito sa kabilang side, no, yung kasama ng hinahanap natin will be transferred, no, sa other side, just like this one. Okay? Nakita niyo ang nangyari? So, naiwan si P1, okay? And then, si P2 at V2, nag-remain lang sila dyan. Pero si V1 is bumaba. Denominator na siya sa kabilang side. If V1 naman yung hahanapin, so take note, V1 yung hinahanap natin. P2, V2 constant, no? Dyan pa rin sila. Si P1 naman yung bumaba, no? Based dito. If si P2 naman yung hinahanap, so dito naman tayo na side. So ito, magiging constant lang, so walang changes. Itong V2 na naman is bababa na naman siya sa baba nitong P1 at V1. Okay? Based na nakita nyo dito. And of course, if V2 naman yung hinahanap, so si V2, yung maiiwan, yung P2, bababa lang siya sa denominator. Just like this one. Okay? So I hope easy lang ito na part sa inyo. No? Again, ulitin ko, whatever is yung hinahanap natin, remain lang siya dyan. Kung ano yung kasama niya, ibababa nyo lang sa kabilang side. That's how easy it is, no, to reconstruct the formula. Okay? Okay, so we are now on our sample problem number 1. Okay, take note, based sa sinabi ko kanina, the temperature should be constant. Okay? A gas sample exerts a pressure of 3 kilopascals. No? So these units, no, has been introduced in the previous video. When it occupies a 12 liters vessel at 20 degrees Celsius, what pressure would the gas exert at 20 degrees Celsius if same gas sample is transferred to a 9-liter vessel? So as what you notice, in here, temperature is constant. So without thinking, no, of what formula to be used, or without analyzing, no, as long as you can see that the temperature is constant, you're gonna be using Boyle's Law. Okay? So we have our given. So the first given is our pressure 1. So in order for you to locate the pressure, just look at the unit that is related to pressure, of course. So we have pascals, kilopascals, ATM, Thor, mmHg. No, so the examples on the previous video. So, for P1 natin, no, pressure 1, no, nakalagay dyan, very simple lang siya i-locate, no. Pressure 1 is 3 kilopascals. Okay? The next one, ang volume naman natin, no, makita nyo sa first part, no, ang volume natin is 12 liters. Okay? And then, of course, we can include, or we should include, no, ang ating temperature 1, which is, of course, 20 degrees Celsius. But again, no, gagamitin natin is Kelvin, no, kasi nga may absolute zero siya. Okay? Another given is the, as what you notice, if the same gas sample is transferred to a 9 liters vessel. Okay? So, meron tayong V2. So, ang hinahanap naman natin is ang ating isa pang pressure, which is our P2. Okay? So, ganun lang pag-determine na sa ating given. By the way, of course, ang ating tawag nito, ating T2. Na though hindi siya necessary or wala talaga siya sa ating formula, pero nilagay ko lang just to be clear. Kasi nga, meron naman dito na mention siya sa ating question. So, for the solution, of course, we're gonna be using our formula, no? The previous, no? Kung paano siya na-construct. So, if you can still remember, no? Ang gagawin lang natin is to determine what is asked, no? So, based dito sa given, ang hinahanap is P2. So, di ba, based sa sinabi ko, kung ano yung kasama niya dito, ibababa nyo lang dito sa kabilang side. Okay? So, P2 is equal to P1 times V1 over V2. So, ganun lang siya. So, ganun lang siya kadali. So, now, we're gonna be distributing the given, no, sa ating formula. So, P2 is equal to P1. Again, yung P1 natin is 3 kilopascals multiplied to V1, which is 12 liters. Okay? And then, sa baba naman, we have our V2, which is 9 liters. No? So, if you're gonna compute that, 3 times 12, okay? So, we have, what? Ilan? 36 divided by 9, no, is equal to 4 kilopascal, no? Ganun lang kadali yung ating Boyle's Law. You're gonna determine, no, whatever is you are looking for just by distributing the given to the formula. So, ang pinaka-crucial dito is you should know how to arrange the formula. Okay? Sample problem number 2. What volume will 500 ml of gas at 600 torr occupy if the pressure is increased to 750 torr at constant temperature? So in here, as what you notice, wala nang binigay na temperature. Sinabi na lang is constant temperature. So yung given natin, so we have our V1, no, na-mention siya sa first part, no, V1, 500 ml, and then we have a torr here. This is pressure. So, this will be our P1. So, occupy if the pressure is increased, no? So, next na given natin is ang ating P2, which is 750 torr. So, obviously, ang hinahanap natin is V2, no? Yeah, what volume, no? Kasi ang question dito. Okay? So, since V2 yung hinahanap, so, di ba? Ito naman yung formula natin. P1 times B1 is equal to P2 times V2. So, since V2 yung hinahanap, yung kasama niya na si P2, ibababa lang natin. Just like that one. Okay? And we'll do the distribution, no, of the given. So, P1 is 600 torr. Ang V1 naman natin is 500 ml. Ang P2 naman natin is 750 torr. Okay? So, obviously, this will be cancelled. No? Cancel itong unit na ito. And ang maiwan natin na unit is ml. So, simple lang. 600 times 500. Okay? If you get the answer, i-divide nyo lang sa 750, no, for you to recheck. And we'll get our final answer, 400 ml. Okay? Okay, so we are now on our sample problem number 3. So this will be my last example. I hope nagets nyo na so far. Madali lang siya if first i-analyze nyo lang talaga yung question. So a gas occupies 12.3 liters at a pressure of 40 mmHg. What is the volume when the pressure is increased to 60 mmHg? So for our given, of course, ang first na binigay dyan, no, is the volume, no, in liters siya. So, we have V1, 12.3. Ang P1 naman natin, ang given dyan is 40 mmHg. And then, the next na given is ang P2 natin, which is 60 mmHg. Yan, 60. Of course, what we are looking for is volume based on the question. What is the volume? Okay? So, since V2 pa rin yung hinahanap, still we'll be using this formula. So, distribute lang natin. P1, 40. V1, 12.3. P2 is 60. So, yan. So, again, this will be cancelled. And ang maiwan lang sa atin is liters. So, 40 times 12 times 3. When you get the answer, divide it by 60 and you'll get 8.2 liters. Okay? So, ganito lang kadali mag-solve, no, for Boyle's Law. So, practical applications naman tayo ng Boyle's Law. So, syringes operate by Boyle's Law. No? I have mentioned that already. When the plunger, ang plunger is this one, yeah, yung gina-push, is pulled, no? So, the more na i-pull natin yan outward, the volume inside the syringe increases, no? Based on the representation of this balloon. causing a decrease in pressure inside the syringe. So when the plunger is pushed na naman, pag i-push natin ito ng i-push, the volume inside the syringe decreases, causing an increase in pressure inside the syringe. So pag i-push natin yan, liliit ng liliit ang balloon. Another one, spray cans used in spray paint and air freshener are governed by Boyle's Law. And yeah, the picture here is Coke. High pressure inside the can pushes on the liquid inside the can and forces the liquid out when the cup is open. Okay, so, diba, the more we shake, no, the can, no, especially yung mga soft drinks natin, once i-open natin yan, mag-burst out yung liquid, no? Kasi nga, too much pressure yung nasa loob. Okay? So, if you have any questions, you can message me lang, no, sa ating GC for clarification. So, I really hope maintindihan nyo ito na discussion.